physics. Yeah, from our last discussion, I was explaining how you can use the ripple tank to study waves. When I say study waves, that means it's something you can do. It's not abstract. Yep. Though you cannot see wave, but you can see the effect of wave, just like heat. You cannot see heat, but you can see the effect of heat. Okay. So in order to make this very simple and not to look as if it's an abstract topic, you can use the ripple tank. So in our last discussion, I used the ripple tank to illustrate what is reflection. I've also used the ripple tank in this animation to illustrate what is refraction. And I think where we stopped was illustration of diffraction. Now, once again, what is diffraction? It's the bending over of waves around obstacle in its path. That is one. And also, it is the spreading out of waves when it come across what? A narrow slit. Now, before I proceed, in the last series, I was trying to give you the condition for which diffraction can occur. All right. Number one is that wavelengths, there is a direct relationship. Please take note of this. Direct relationship for wavelengths. Okay. Direct relationship for wavelengths. And then there is an inverse relationship for what now? Inverse relationship for the slit. Now, what is slit? I told you the narrow opening is what is called slit. We don't call it opening, we call it slit. S-L-I-T, slit. Okay? So, what do you think will happen if a barrier is placed in front of okay, I've explained that. Placed in front of water. Now, what do you think will happen if a barrier with a gap in it is placed in front of the water waves? Diffraction will occur, but it's not in every instance. The two conditions must be fulfilled. And what are those two conditions? Number one, direct relationship for the wavelength. The wavelength is directly proportional to the diffraction. What does it mean? Increase in wavelength, increase in diffraction. Increase in wavelength, increase in diffraction. Now, the slit, the opening, is inversely proportional. What does that mean? Increase in the slit, less diffraction. Now, decrease in the slit, more diffraction. So in a situation where you place a slit that is less, that the dimension is less than the wavelength, what do you expect? From what I've just said, what do you expect? There will be no diffraction. Look at it. I'm going to animate this. It depends on the size of the gap, okay? If the gap is smaller than the wavelength of the waves, what do you think will happen? I've already given you the answer. I told you it's an inverse proportion. So if the gap is smaller than the wavelength of the waves, what will happen? Let's look at this now. See the waves being generated, the parallel lines, okay? What happened? No diffraction. Because what I'm seeing now, the waves are reflected by the barrier. They are reflected by the barrier. Now, what will happen if the width of the gap in the barrier is similar in width to the wavelength of the waves? What will happen? Okay, here we are. All right, there is diffraction there. Circular waves are produced. This effect is known as what? Diffraction. Did you notice anything? What was produced is plane waves because of the paddle. The paddle was rectangular in shape, so the paddle produces what? Plane waves. But what is being diffracted here is what? Circular waves. That shows what? Spreading out. So this is what is called diffraction. The ability of wave to do what? To spread out after passing through a narrow opening, or the ability to bend over an obstacle and then continue its journey. All right, so let's continue. What will happen if the width of the gap in the barrier is larger than the wavelength of the waves? What do you think will happen? I gave you two conditions. Condition number two, inverse proportion. Here we have the width of the slit being larger than what? The wavelength of the waves. Even without telling you the answer, what do you think will happen? I told you inverse proportion, isn't it? Inverse relationship. So if the gap is wider, then what will happen? Let's check. Animate. So we have this. Okay, the waves pass through the gap unchanged, apart from the slight diffraction of the waves near their ends. What did you notice? We almost not have what? Diffraction, because the gap was actually wide. It's not as if the wave will not pass, but the diffraction will be less. What is diffraction? Spreading out. From what you have seen here, the spreading out is not much because the gap was what? Wider than the wavelength. I hope you got that. All of this is how to study properties of waves using what? The ripple tank. So it's something you can do at home, and it will make physics so real and so interesting for you, okay? Now let's continue. Effect of diffraction. All right, effect of diffraction. How can the teacher in the corridor hear the school band even though he isn't in the hall? Now look at the picture there. Look at the scenario painted there. All right, this is the school band. Music is going on, but the teacher was outside as at this time. The teacher is still outside anyway. Look at this one here, okay? All right, this is a school band. The teacher is outside, but how is she able to hear the music? How can the teacher in the corridor, okay, hear the school band even though he isn't in the hall? That is what we are talking about, diffraction. Okay, the door of the school hall is open. So while the music was going on, the sound, what happened? Diffracted out. The sound came out of the opening, and from there, what happened? It diffracted. So the teacher does not need to stand at the door. No, the teacher can be anywhere around the hall, yet he or she will be hearing the sound. Why? Because after the sound must have passed through the door, it diffracts. Okay? That is one of the effects of diffraction. I want to believe you got that explanation. Let's move forward. Now, light and sound are both waves. Light and sound are both waves. I explained this in the last series, okay? Light, electromagnetic waves, is a class of electromagnetic waves, and sound belong to the class of mechanical waves, because you cannot produce sound without a material medium. Do you remember that? I explained in the other series. Now, light is an example of electromagnetic wave. Remember the definition for electromagnetic wave? They are what? Radiant energy. So light, radiant energy. Light and sound are both waves. Waves travel in straight lines. Yes, waves travel in straight lines, okay? When you are in a room, why can you hear people in the corridor even though you can't see them? You know, I told you I'm trying my best to see how I can bring this closer to your environment so that you can easily relate with this topic, okay? I just want to ensure that the misconception about waves being an abstract topic, you know, is being handled here. So this is an experience that we all have every day, okay? When you are in a room, you are in your room, okay? Why can you hear people in the corridor even though you can't see them? Okay, even as I'm here right now, I can hear people talking outside. But how come I'm not outside? I'm in the room. So how come I'm able to hear them? It's one of the effects of diffraction. What happens is that the sound waves from whatever they are doing passes through the door, or if the door is closed, I told you before, even if you close your door, there is a gap of 0.05 millimeter opening. Okay, even 0.01 is enough, okay, for sound to pass. All that sound wave needed to do is just to pass through that opening. And once it has passed through, the next thing is to diffract. And what is diffraction? Spread out, okay? It's spread out so I can hear people from outside, provided there is a little opening, either from my door or from the window, okay? Now, when you are in a room, okay, I've explained that light waves have much shorter wavelength than sound waves and are not diffracted by the doorway. Okay, did you get that? Did you get that? Light waves have what? Shorter. Light may not diffract. For example, if there is light outside there and this door is closed, the light may not diffract. You might end up having shadow. Okay, we'll talk about that in another series. You might end up having shadow. Okay, but for sound waves would actually do what? Pass through. The reason is this: light has what? Shorter wavelengths. Sound has longer wavelength. So with this advantage, sound can diffract. Light may not diffract easily, except if other conditions are in place. But that does not mean light cannot diffract. It can. But if the condition is favorable, okay? Does that make sense to you? Sound waves have a wavelength similar in magnitude to the width of the doorway, and so diffraction occurs. Yes, it has a wavelength similar to the width of the doorway, and so diffraction occurs, bending. All right, so we are through with diffraction. I'll be going into interference, but before we go into interference, let me do a little recap. Maybe I'll take interference in the next series. Now, so far so good. I was trying to explain how you can use the ripple tank to study wave at the comfort of your own house. Okay, at the comfort of your own house. How you can use it to study wave and then see how interesting wave can be. All right, so I've used the ripple tank to explain almost 4 properties of waves. I gave you 5 properties. Yes, we have 5: reflection, refraction, diffraction, interference, and polarization. With the help of the ripple tank, you can study 4 of those properties of waves. You can study 4. Is that okay? All right, so let me just do a little recap again, then I will take interference in the next session. Is that okay? All right, I said a ripple tank is a device. Did you get that? I said a ripple tank is a device used in doing what? In studying waves. All right, I hope that makes sense to you. And what are the components of a ripple tank? Once again, it has what is called paddle. It has what is called dipper. Okay, the dipper is to create pulse, and when multiple pulses are created, that will result to what? Disturbance. And when you have disturbance traveling through a medium, that is known as what? Waves. I hope you got that. All right, so in a ripple tank experiment, all you need to do, create the wave, and then to study reflection with a ripple tank, what are you supposed to do? Remember, place a barrier in front of the ripple tank. What is the function of the barrier? To stop the wave, okay, and make the wave do what? Bounce back. The bouncing back of that wave to where it was coming from is called what? Reflection. Bounce back, reflection. I gave you example: reflection of sound, echo; reflection of light, as in plain mirror, seeing yourself. Okay, now I also explained how the ripple tank can be used to study what? Refraction. What is refraction? In case you have forgotten, it is what? The change in speed and direction. Let me write it up. Refraction, refraction is what? Is the change in speed, okay, and direction. Okay, there is a change in speed, there is a change in direction of what now? Of the waves, change in speed and direction of the waves. Now, when what happened? When it crosses the boundary, when waves, okay, when wave cross the boundary, okay, I did not write that before, so I have to write it out. Boundary of 2 media. 2 media here refers to different medium of different density. two media. Sorry, this should be media. I can't get my eraser now, but let me just cross this. So this should be media, two media of what? Of different densities. This is the only way that refraction can take place. Okay, different density. The only condition for refraction to take place is what? The two media must have different densities. So in ripple tank, how do you do that? How is that achieved? So all you need to do is to place a block inside the tank of that device called ripple tank. Now, what is the function of the block? What will the block do? The block will help to create two layers of depth. So you are going to get a deeper depth and a shallow depth, okay? Where you place the block is going to be shallow, all right? And then where the block does not extend to is going to remain as the normal depth. Now, once you transmit this sound, what will happen is that the sound will be refracted, okay? The change in depths of the water causes a change in the speed of the waves. They are refracted. So the sound will be refracted, change in direction, change in speed. Okay, and then the same ripple tank can be used to study what? Diffraction. What is diffraction? Change in what? Ability of wave. It is the ability of wave to spread out after passing through a narrow opening, or the ability to bend over obstacle. So how do we display this on the ripple tank? Very simple. Place a barrier with an opening, okay, and see what will happen. Okay, and I've also given you the two conditions for this to happen. Okay, there are two conditions for diffraction to take place. Okay, so what is diffraction? Just look at the animation, that should help you. The parallel lines are the waves, okay? Here we have bouncing back. The reason is because the opening is far, far smaller than the wavelength. The opening is too small. But if you make the opening equal to the size or close to the size of the wavelength, then the situation will change. Look at this now, a wider opening, the same waves being transmitted. But what did you notice? Diffraction. Now check out the level of the spreading out, because I'm going to do the next one, then you spot out the difference for me. So look at this, see what has happened. It passed through the opening, and what is that? You can see something like a cone spreading out, all right? See something like a cone spreading out, all right? So that is diffraction. Now if you make the gap wider, what will happen? The wave will still pass because we have an opening, but the diffraction may not be much. In other words, the spreading out will not be much as compared to what? A narrow opening. Now see what is passing there. We almost have plane waves passing, almost having plane waves passing there. Then the bending is just small. Look at it, very small. Okay. Now I've given you the effect of diffraction, okay, the school teacher and all of that, and then I've also given you the distinction between light and sound waves. Okay, I've explained why light to some extent cannot diffract where sound will diffract. That does not mean that sound cannot diffract, but light cannot diffract, but at some conditions, it may not favor both of them, light and sound, for that to happen. So I just have to do a recap on all of that for you to really understand how to use the ripple tank to study wave at the comfort of your house. Thank you very much. We'll meet in the next series for interference of waves.